Actually, data visualization is everywhere, and I want to show you some examples that I picked from different sources. Well, right now, newspapers publish a lot of data in form of graphs, especially when they use internet. So this is actually something that I caught on Twitter, and it's drawn by the Financial Times. It's just simply a bar plot. Also, the Financial Times plotted this graph here, which is a line plot, which is trying to plot the NHS hospital waiting lists in England. Also, in newspapers and in the internet, we can find infographics, and actually infographics are pretty much everywhere. This is from a Spanish newspaper called La Vanguardia, but this is also from BBC, the newspaper, okay? We can see some infographics that are really well done, like this one here, but they're pretty much everywhere. You can also see data visualization in bills. Actually, this is my own gas and electricity bill. And as you can see here, in just these 2 pages, we can see that there's a bar chart, some sort of a pie chart, which is split in the middle, and then 2 3-dimensional pie charts. Actually, because I wondered if this is the normal thing, I Googled for an electricity bill from a company in the United States. This is from Green Mountain Energy. I don't know if this is a very well-known company or not, but actually there's a graph here as well, which is the typical bar chart as well. You can also find data visualization in user interface design, especially in those apps that are meant to show numbers. For example, in banking apps, this is from a bank in Spain, and also from applications that show fitness data. Like, for instance, the left one is the Adidas Runtastic app, and the right one is this iWatch, which shows you how many steps have you done, how much have you spent, the number of calories, and so on. We can also find data visualization in any kind of website. Actually, this is from TripAdvisor, and this is a restaurant in New York. And as you can see here, there's the rating, which is depicted with these circles, and also the ratings for food service and values and atmosphere. And then we have the traveler rating, which can be excellent, very good, average, and so on, which is represented using a bar chart. So actually, websites are using data visualization more and more. And actually, the good part about using data visualization on websites is that you can make the graphs interactive. And this is something that is very powerful and that agencies are using more and more every day. Of course, you can also find data visualization in the typical business reports. So, for example, if you are a manager in a company, probably you have to draw one chart like this at some point, in which you just show the revenue or the expenses of the company or the comparison with another company, as the case here. In health reports, we can also see data visualization. This is actually from the Center for Disease Control. This is pre-COVID, so actually this is not the incidence of COVID-19. Of course, we will find data visualization in scientific papers, and it is pretty specialized. It's not so beautiful, let's say, at least the majority of it, and it's more technical, but it is improving every day. And actually, you can even find data visualization if you go to your dentist. Actually, this is from my dentist, and I hope that this is not too much information. And this is actually meant to depict the health of your gums in 3 colors, black, yellow, and red. So actually, really, data visualization is everywhere. But what I'm worried about is, are the previous graphs examples of good data visualization? Actually, I have to say that when I picked all of these examples, I was focusing on finding examples from different sources, and I wasn't looking particularly at the examples. But then I went back to the examples and I found some problems. So let's just review them. Actually, in this case, this plot by the Financial Times, it has colors that are very bright, so actually it is very difficult to see. Also, the categories are too close with each other, so it generates some sort of moire effect. This other plot from the Financial Times as well, which is showing us the waiting lists for the National Health Service in England from 2007 to 2020, has a different kind of problem. Here, as you can see, if you look at the right, it says NHS Confederation estimate. So actually here, different data coexists in the same plot. Real waiting times that have happened and an estimate of waiting times. So actually, this is something that is misleading because here we see that there is going to be a huge peak in 2020, which is not a surprise considering the coronavirus situation, but this is an estimate. It's not something that we know that has already happened. So this is something that we will learn in a future chapter, which is called showing design variation and not data variation. In this infographic that I showed you before from a newspaper, here we see a lot of information about the causes of snow avalanches. And I want you to focus on this one here, and let me translate it for you. Here it says, most snow avalanches with mortal victims were caused by humans, and we can see the information here on the bottom, which says the origin. So 17% is unknown, 22% is natural, and 61% is accidental. But actually, what I'm focusing here is on the size of this graph. So actually, if you take the newspaper as it is printed, I mean the printed version of the newspaper, this image occupies 9 by 15 centimeter. So to understand how much this is, I just compared it with a piece of text of the same size and of the same newspaper. So actually, in 9 by 15 centimeters, there's a lot of text that can fit. And here what happens is that we are using this area, which is pretty big, to just depict 3 items of data, which is the 3 origins of snow avalanches. So actually we are just showing here 3 numbers. So my criticism here is that space and users' attention is wasted for giving just 3 pieces of data. Also, I would like to ask you, if I remove the labels that say 17% unknown, 22% natural, and so on, would you have guessed the actual proportions of the causes of snow avalanches by looking just at this area plot that resembles a mountain? I'm guessing no. So actually, this whole plot is just simply a decoration. The only information that we perceive here are the 3 numbers and the 3 causes. So why should we waste so much space if we are going to provide so few information? Going back to my electricity bill, I would like to take a look at these 2 graphs here. In the top plot, we can see the gas and electricity consumption. And as you can see, it is represented by a bar chart in which we have red bars. But actually, not all bars are red. There are some of them that are orange, which are the ones that I'm pointing with arrows, and they depict the estimated consumption, not the real one. Okay, so it is a good idea to differentiate between the estimated and the real consumption. At least it's a better idea than that plot with the NHS waiting lists. But the choice of colors is making it really hard to differentiate between the red and the orange bars. It is difficult to me, and I do not have any kind of color blindness. So imagine how difficult it must be for those who do. The second plot is even worse. Actually, these 2 3-dimensional pie charts try to depict the source of the energy. So for example, the green one means that it's renewable, or the red one means that it is produced by burning coal, and so on. So actually, to understand this plot, what you have to do is, if you go to the gas one and you see that there's a slice which is red, then you have to go all the way to the right, look for the red legend and read that, okay? So labeling is better than having to decode color. All of this effort that we are asking the user to do could have been replaced just by simply putting a label. That's my first comment. The second comment is, this is a pie chart with 8 slices. How effective is this in communicating the numeric values that are represented here? So let me just rephrase this question. If I remove all of the numbers that appear in this graph, would you be able to guess the correct proportions of each one of the slices of the pie? Let me tell you in advance, no, it's impossible. And also, what is the 3D shape doing here? Is the 3D helping us transmit information, or is it distorting a little bit the angles of the pie chart? This is something that we will discuss in a future lesson as well. Now let me go back to the example of this interface of this banking app, where we can see another type of problem. Here we can see that it depicts the expenses and the income. And we have a blue bar and the yellow bar, and then we have the numbers. So actually, the income is more or less 3,000 euros and the expenses are more or less 1,000 euros. Actually, if we calculate the ratio, the income is 2.7 times the expenses. But actually, as you can see, the yellow bar is not 2.7 times the blue bar. It's not even the double. So actually here we have another sort of problem, which is that the bars representing the income and the expenses are not proportional to the numeric value. So they are giving the reader a false impression. So, going back to our previous question, are the previous graphs examples of good data visualization? Well, sadly, they are not. Houston, we have a problem. And in the next chapter, we will discuss what is the problem exactly and how we can solve it.